Hello everyone, my name is Krishna Sharma and my student ID is 24DCS117. I am a BTech Computer Science student and today I am going to talk about Advanced Driving Assistance System, that is ADAS and digital electronics. Now ADAS is a technology which makes our cars smarter and safer. So now let's get into our presentation that what is the main role of ADAS in the future vehicle or a modern vehicle system and how is digital electronics related to that. So starting with the presentation, all this we already talked about earlier that how digital electronics and ADAS are related to each other is going to be explained in this presentation. So getting into ADAS. Now, from definition, we can easily say that ADAS automates and enhances vehicle system, which improves the driving safety. And its major goal is to reduce the human error and enhance the driver comfort. Like it also prevent the accidents. Now, some of the examples of features of ADAS is ACC, LKA, AEB, BSC system. Now, what is ACC? ACC is the adapted cruise control. LK is lane keeping assistance. AEB is automated emergency braking system, and BSD is the blind spot detection system. Now, it is projected that the market growth of the ADAS is going to reach about $65.9 billion by 2027. And yeah, we can see it's the reality that it is going to reach because nowadays we are completely based on technology based things around us. Now let's talk about that how ADAS came into existence. So the first adaptation of ADAS was in 1900. So we know that during 1900s there were no technology present. Like it was a period which was a very low period that during that time not many things were discovered so that people can use those things and create something new. So yeah, it was first adapted in 1900. So the first cruise control system was patented in 1900. These early systems were mechanical. So we can say that as there was no technology during that time, everything was based on mechanical. Basic driver aids focus was primarily on basic aids. Example include automatic transmission. Next is limited technology. As I said that there were at that point of time there was no technology. Like it was there, but it was very less. Technological capabilities were limited. Systems were mostly mechanical and electromechanical. So we can summarize from this that during 1900, cruise control system was patented, and it was mostly based on mechanical and electromechanical thing. Next is journey of this cruise control system, or nowadays we talk about it as a ADAS system, was uplifted during 1950 to 1970s. So in 1950s, first electric component was added into automobiles. Then next was Cadillac Cyclone. Now, what is Cadillac Cyclone? In 1958, this Cadillac Cyclone named radar-based collision warning system was invented, which was used in the ADAS. Next is sensor advancement. Advancement in sensors and microprocessor remained rudimentary. Emergence of modern 1980s and so now we are talking about the 1980s and 1990s period. Like how was ADAS uplifted during that period of time? So next, it was ABS and TCS, where ABS stands for Automatic Lock Braking System and TCS stands for Traction Control System. These two things were developed during early 1980s. And the next thing which was developed was Electronic Damper Control, which is EDC, which was first introduced in 1998 in BMW 7 Series car. So this feature was first tested in that car and then it was adapted further. Next was sensor integration. Gradual integration of sensors and control system began during that period of time in 1980s and 1990s. Now here come the year, that is 2000, where the actual advancement of ADAS took place. Now ADAS has come long way over the years, like we have seen that it started from 1900 to 2000. So in 1900, first cruise system was introduced, and in 1950s, the early radar-based collision system were developed. In 1950s, after 1950s, there came a period where the electronics was introduced into the ADAS, that is 1980s to 1990s. ABS, that is anti-lock braking system, and traction control became the standard thing of the ADAS system. And now we are talking about the 2000 and beyond, that how it will take place. Like right now we are living in 2025. So you can imagine that how much advancement must have taken place during that period of time. So in 2000, the AI cameras, lidar, and radar made ADAS more advanced system and reliable were introduced in 2000. So first is electronic stability control. Electronic stability control, that is ESC, became widely adopted. Adaptive cruise control that and lane departure warning system LDW were introduced during that time. Next is sensor development. Radar, lidar, and camera based sensor technologies were developed, as I said earlier. So next is rise of automated driving in 2010s. Like how people got to know about this ADAS system, and people have strongly started that started to develop the interest toward this ADAS based driving. So first is automatic emergency braking, the feature which attracted the most of people. Like during the emergency time, automatic braking was the most important feature. And next was lane keeping assist, like a car can change the lane automatically using its sensors. And the most interesting thing which we are attracted more is Tesla. Like Tesla has introduced a lot of technology based on the ADAS, and how it is actually making it real for us to believe that a car can run automatically on its own and do everything which a human can do. And also it ensures the safety and a smart approach towards the vehicles. So going forward, ADAS and the future of mobility. So what is the future of ADAS and how it will be useful? So first is, already we are saying the same thing again and again, that is impact on safety, driving experience, and future trends. What are the challenges which we will face using that? So going forward, types of ADAS feature. ADAS includes several key smart features that work together using advanced sensors and digital electronics. So, first is adaptive cruise control, that is ACC. This is the feature which uses the radar and cameras to adjust speed based on the traffic condition. Then next is departure warning, that is LDW, and lane keeping assistant, that is LKA. This detects the lane markings and alerts or corrects the car if it drifts. Like if your car is moving in one lane, then it can automatically change to the another lane based on the condition of the road. Next is automatic emergency braking, that is AEB, which uses a sensor to detect the obstacle and apply brake when needed. Next is traffic sign recognition, that it reads the road signs and displays them on the dashboard, and based on that it reacts relatively. Each of these system relies on combination of cameras, radars, lidars, and microcontrollers to function smoothly. You can see that the given below examples of like how this are used in the cars. So ACC was used in Tesla Autopilot, Nissan Pro Pilot Assist, and then lane departure warning, that is LDW, was used in vehicles of Honda Sensing, Toyota Safety Sense, etc. And AEB, that is automatic emergency braking. The examples was Subaru Eyesight, Volvo City Safety, etc. There are several examples like this, so we can take the reference of those and see the features of ADAS. Adaptive cruise control and ADAS enhancing safety and convenience. So, as we have already discussed about ACC in ADAS, how it ensures the safety and convenience of driving car in modern vehicles. So it is much important to see how adaptive cruise control works. So first, distance monitoring. Radar and sensor maintain a safe following distance from other vehicles. Then it adjusts the speed according to that on the basis of the flow traffic. Then stop and go. ACC functions even in congested traffic condition manages stop and go and go. ACC utilizes radar and sensors to monitor the distance to vehicle ahead, control algorithms, then just adjust the car speed to maintain a safe following distance and studies how it reduces a rear end collision. So it can be observed that how this technology works effectively. Next is traffic sign recognition. That is technology that is also based upon the technology and functionality. Camera based TSR, image acquisition, processing, and sign detection. Like it detects the sign using its camera and reacts accordingly. Next is database integration, matching detected signs with onboard databases for accuracy. Next is real time display, presenting crucial information to the driver in a timely manner. TSR system uses camera to capture images of traffic sign. They then processes these images and compare them to the onboard databases which are already stored. And the databases recognize the recognized signs are displayed to the driver in the real time. And this is how the traffic sign recognition works. Next is ADAS sensor suite, like how sensors work in ADAS. The effectiveness of the ADAS depends on the sensor and digital electronics. Now here is how they work. Cameras. Cameras identifies lane, traffic signs and pedestrians. Radar. Radar measures the speed, distance of the nearby vehicle, etc. LIDAR. LIDAR creates a detailed 3D map of a surroundings. Ultrasonic sensor. Ultrasonic sensor helps in parking, detecting close objects, microcontrollers and digital signal processing which processes the data and make a real-time driving experience or a decisions. Now all these components work together to ensure that the ADAS function reliably in driving conditions. Like if it is kept in the heavy trafficking area, then also it should work efficiently, and if there is an empty road, then also it should work efficiently. Digital Electronics Microcontroller MCU. Now, here comes the main important topic, that is how digital electronics is connected with the ADAS technology based driving assistant. So, role is MCUs are central processing unit for ADAS. That is, microcontroller units are a central processing unit of ADAS. Like from there, a signal reaches to the vehicle that it has to do this operations and it has to do that type of operation. Next is function. They process sensor data and controls actuators. Like they receive some sensor senses the vehicle around it, and then this sensor data goes to the actuators, and it gets functioned over there. Next is architecture. That how it is designed. It uses ARM Cortex M series and RISC-V architecture. Automotive grade AEC-Q100 qualified for reliability and temperature. So these are some of the role, function, architecture, and automotive grade of digital electronics used in the ADAS system. Moving forward, digital signal processing, that how it is processed. So the sequence is first is function, second is algorithm, and third is hardware. Function. Function is for real time processing of sensor data. Algorithm, which uses the Kalman filtering and Fourier transforms. Now these are some of the earlier features featuring, or we can say that earlier invented transformations which were made using this algorithm. Next is hardware, which is dedicated DSP chips and FPGAs are used in the ADAS. Communication protocols CAN bus. Function, standard and data rate. Function in vehicle network for ECU communication, standard controller area network, that is CAN, and data rate, that what is the data rate of the CAN, that is up to 1 Mbps, and CAN FD up to 5 Mbps. Protocols Ethernet. Function, standard, data rate, and security. For function, high bandwidth communication for ADAS. Standard, which opens the doors for the automotive Ethernet. Data rate, 100 Mbps, 1 Gbps, 10 Gbps. And for security, features enhanced security. Now, to understand this ADS in more detail, we must study the Tesla's autopilot system, that how it works. Tesla's autopilot is one of the most advanced ADAS systems available today. It integrates adaptive cruise control, traffic sign recognition to assist with highway driving, over the air software updates that continuously improves the performance, and data from the million of miles driven to make self-driving technology more accurate and efficient. Tesla's data shows that accident per mile driven are lower than the autopilot is unable, proving the effectiveness of the ADAS. Now, to understand this in more detail, I would like to show one video presentation to you. Here it is. As seen in the video, you can see that how minutely the designing of Tesla was done, and how accurately the things were done through that. Performance evaluation and real world testing. Environmental condition, like it can also measure the weather, lightning, and visibility impact. During rainy season, we always face the problem of fog on our car windows and car front shield. And to overcome all this, the performance evaluation and real world testing is done for environmental conditions. And then road infrastructure, like if the roads are having potholes, then also it can detect it. System limitation, addressing potential errors and implementing fallback strategies. TSR accuracy is affected by environmental conditions and road infrastructure. All these limitations were checked up, and it was created very efficiently, that it can always detect all those conditions. What are the challenges and future trends? While ADAS has improved vehicle safety, there are still challenges. Like not every challenges is for not everything is proper. Like it has some error in it, and we must solve it. First is weather condition. Sensor may struggle in fog, rain, or snow. It might sometimes not detect everything, but also it can give false alert. That is, AI need improvements to reduce unnecessary warnings. Legal and ethical issues. Governments are still developing laws for self-driven vehicles. In the future, AI powered ADAS sensor fusion and Full automation will make driving even safer and more efficient. Companies are working on the better AI algorithms and improved sensors to overcome the current limitation. ADAS is revolutionizing the automotive industry with the help of sensor, digital electronics, and AI. Now, cars are becoming smarter, safer, and more efficient now. As technology continues to evolve, ADAS will play a major role in transition to fully autonomous vehicle. Like it will be fully automatic. Like human need to do nothing. He or she just have to sit at one place, and car will take them to their required destination. As technology continues to evolve, ADAS will play a major role and which will lead to the future with fewer accidents and safer roads for everyone. Thank you.